Hi, so today I will be sharing about my HF topic that I'm working on and where do I get my reference from. So for my topic, it will be split into three parts. For part A, will be explain what an iceberg model of accident means. And then for B, it can be very costly to economical design something to accommodate 100% of the population. So what is the traditional choice of design population percentile for most civilian application? Then for part C will be the most well-known of the various types of errors, which are the three different errors: slips, lapses, and mistakes. And I'm supposed to distinguish these three types of errors and give one example for each of them. So coming for the first part, the iceberg model of accident. So for going through the CAP715 model, right, it does not actually exactly label the iceberg model. So I searched online for an example. So it will be from this website here over here. So it say the accident theory. So for here, they say that in our career, we have come across accident triangle theory, which for one example is like for every 10 serious accident, 100 incidents, and 1,000 minor incident with similar event that did not end up as an accident. So this is like an iceberg model. So the idea here is to look at the border base of the triangle and by comparing their statistics, recognize when something is deemed to happen or so that we can do an action earlier to avoid the accident from happening. Then for the second part of the iceberg model would be like the CAPS 758. Emphasize the human factors are present like somewhere in causal chain of in most accident, which is from another website, which actually is a PDF file that I found online. So from here it's actually by the Australian government. So over here it states about the safety behaviors, everything over here, which I get my resources from. Then now coming to part B about the traditional choice of design population. So for the example I found would be from this slide over here. So for by the percentile humans, anthropometric dimension for each population are ranked by the size and described as percentile. Then for its common practice to design for 5th percentile female to 95th percentile of male. So this is all how it works over here. Then coming to the last part, which will be the three different type of mistakes: slips, lapses, and mistakes. So for all these thing, I found it in another file. It's like a e-document over here. So at this part will be the slip, lapse, and mistakes. So for here is where I get my reference. A slip is the error of execution, which the plan and intention is incorrect. So for example, it's like hand-eye coordination fails or attention wanders. Then for lapses is an error of memory or omission, which is against the intention, which may be correct. For example, is during a complex inspection, the engineer forget to place the safety tag back on the connector somehow. Then for the last one would be mistakes. So the mistake is an error of planning and decision. The intention is already wrong because the person applies the incorrect rule. So for one example, there's the engineer follow a procedure that's outdated or misinterpreted in the maintenance manual and use the incorrect doc setting or a book because he believed it was the correct one. So there's a mistake. So that comes to the end of my sharing and where I get my reference from.